And that is essentially how you would find the arc length when you're given the formula for the curve. And that's 1/4 of what we were going to cover today. Put a little check mark on it. And bring this guy down again. Just, oops, wrong fella. There we go. There's the end of the guy. Is there any questions before we move on to our next bunch of questions about how to calculate arc length? Okay. So the next thing that we're going to be looking at in our list of topics is finding things. Excuse me for a minute while I get my windows back. There we go. Is finding unit tangent vectors, unit normal vectors, and what are called curvature. So let me start with curvature. The function is basically the curvature of a space curve at any given time t is given by this funny little guy, and that isn't just a weird k, it's actually a Greek letter called kappa. So I would say curvature is kappa t. Now I want you to imagine that we have a space curve in 3D space. Curvature is a number. It's a scalar that tells us how curved a curve is. You think, well, what on earth do you mean by how curved it is? Well, if I said to you that curve is not very curved and this one is, would you agree you kind of know what we mean? It curves quickly, it curves slowly, right? Kappa is a number that tells us at any given point in a curve, because for instance, in this curve here, isn't that place pretty, you know, curved, and maybe this bit over here is very uncurved, right? We would have a single value for every point on the curve, a single value of this thing called curvature, and it would tell us how curved something is. So straight lines have a kappa of 0. Would you agree that straight lines are the least curved thing in the universe? Now, if you have a, let's do circles. If you have a circle like this, and a circle like this, and a little circle like this, each one of these are curved, but bigger circles are less curved than circles with small radius, right? So this guy might have a kappa of 20, this might have a kappa of 10, and this might have a kappa of 5. And circles have the nice property that every single point in the curve has the same curvature, right? So I could say any point in this curve, its kappa would be 5. Anyone in this one, it would be 10. Anyone in this one, it would be 20. This is really just an anomaly. But just for completeness sake, if a straight line is 0, and you go kappa is 5, then kappa is 10, then kappa is 20. If you did a circle whose kappa was 1,000,000, and then did a circle whose kappa was 20 billion, what would a shape look like if its kappa, its curvature, was 0? What on earth would a shape whose curvature is infinite be? And it's a strange answer. A single point in space, which you might have thought was the exact opposite. But can you imagine that a circle got smaller and smaller? What would happen if a circle disappeared? Wouldn't it disappear into a point? So that's the argument. So All you're getting is the theory behind it. So how do we come up with this number? If you take any point on a curve, let's do a new curve. Okay, so here's my space curve. Suppose I was interested in the curvature at this point here, right? Let's call it t equals a. What you can construct is a circle that has the same curvature as that. So can you imagine there might be a circle like that at that point, its curvature and the circle would be the same, right? We both curve the same. You then calculate the radius of that circle. Let's say the radius was 4 units. Kappa, the curvature at that point A, is 1 over the radius. It would be a quarter. Now, why does that work? Well, if you've got a big circle, won't the radius be big? So won't 1 over it be small? And big circles have very little curvature to you. So that's the theory behind how to calculate curvature. What does it look like as a formula? Because it is a formula. The curvature at any given point t of a space curve r of t is given by, just make sure I got it all here, the magnitude of the first derivative cross product with the magnitude of the second derivative divided by the magnitude of the first derivative cubed. Now, you don't need to worry where on earth did they get that formula, and it doesn't look like it has much to do with the circle. Can you just do the, trust me, I'm a mathematician, this is the formula. Now, to be able to calculate this formula, we are going to have to do an awful lot of work. We're going to have to find a first derivative, we're going to have to find a second derivative, and then we're going to have to do a cross product, then the magnitude of this, and then divide it by this guy cubed. So any question involving curvature is by its very nature going to be time consuming. So I guess we should get started. So there is a single question 5 that just gets you to do this and nothing else. And so the space curve is a 9t, a t squared, and a t cubed. Oh, and by the way, there are alternate formulas to this, but in this context here, this is the one we're going to use. So I need to find the first derivative, which is 9, 2t, and 3t squared. I also need to find the second derivative, which in this case is 0, 2, and 6t. Are we comfortable about it, the first and second derivative? Right? First derivative, second derivative. Now we're going to do the cross product. Well, the cross product of the first derivative with the second derivative is going to be an I, a j, and a k. And the first derivative is 9, 2t, 3t squared. And the second derivative is 0, 2, 6t. So if I cover up, our answer is going to be so many i's, take away so many j's, plus so many k's. Oh, and I forgot to tell you, this question wants to know the curvature, right, at the point 9, 1, 1. Now, at the point 9, 1, 1, what is the value of t that would generate 9, 1, 1? because we need to know that t value.
One.
Agreed. So, in this particular question, I'm doing it much more general than I needed to, because actually, couldn't I just replace t equals 1 here and here and get numbers, right? But, you know, since I've done it, I might as well keep going. So in this case, it's going to be 12t squared. Take away 6t squared. The middle one is going to be 56t, take away nothing. And the last one is going to be 18, take away nothing, which gets me 6t squared, negative 56t, and 18. And I think it's probably a good idea to plug one in now, so I probably should have done it earlier, but it's 6, negative 56, and 18. And that is only the cross product done. The formula needs to know the magnitude of that cross product. So the cross product.
You plugged in one to the cross product, the R prime, R double prime?
Yeah, I should have probably did it earlier, but I didn't. Right? I should have put it in here, if that's what your question was.
Real quick, where did you get the 0.911 from?
It was given to us in the question.
Okay,
We were
cool.
told it. So this guy, right, becomes the magnitude of this vector. So it's going to be 6 squared plus negative 56 squared plus 18 squared. And I am going to one day remember to not leave my bag. So I'm going to have to, has somebody got a calculator handy and tell me what that horrible square root is equal to? While you're doing that, I will now find the magnitude of the vector at 1 cubed. Well, this guy is 9, 2, 3, and the magnitude of it is the square root of 81 plus 4 plus 9, which is what? The square root of 94. And then you cube it. Right, have we anybody got the value for this ridiculously ugly number? Okay, it's 42, because nobody will tell me and I can't do it in my head. So whatever it really is, you'll put that number there. And this fella then is going to be...
Are you looking for 3,841, I think?
Maybe. 3,841 will do well.
Okay.
So it's going to be the square root of 3,841 over the square root of 94 cubed. And that horrible thing, that number, and it is a number, is going to be simplified down to 1/47, the square root of 819 over 94. So evidently that square root simplifies and this square root simplifies, and that's what you get. And seems reasonable, at least the 94 does.
So then most of these problems, they're going to come with the point where we have to put the value in.
Yeah, they are.
Okay.
They're going to come with a point where we have to put the value in.
Or we have to figure out the point.
Oh, not necessarily. Yeah, not necessarily. I'm looking at the next question. And not all questions are equal. So you may get a question where you plug in t equals 1. You may get a question where your answer is just got t's in it. Right? If they don't give you a point, then you're just generalizing it to kappa of t. If they give you a t equals 1, then you're going to plug in a number and get a number as your answer. Now I'm going to